According to their response to electrostatic field, most everyday objects belong to one of the two large classes, namely conductors and insulators or dielectrics. Metal, plasma, etc. are good conductors of electricity. Substances like ebonite, mica, rubber, wool, plastics are insulators or dielectrics. The term insulator and dielectric are applied to more or less the same substance, but each term means a slightly different property. Insulator means that there can be no flow of electric charges through the substance, but in dielectric, though it does not conduct electricity, it transmits electrical effects. All insulators are not dielectrics. Then dielectric means the substance which can transmit electrical effects. So it means that when a dielectric is placed in an external electric field, induced charges are produced in it, or a dielectric create an electric field internally under the action of an external electric field. Unlike the conductors, where the electron is not attached to a specific atoms or molecule, in a dielectric, all charges are attached to a specific atoms or molecules. That is, an electron in of the dielectric atom are rigidly bound to the respective atoms. But they can move slightly within the atoms or molecules. The cumulative effect of such a microscopic displacement accounts for the characteristic behavior of dielectric material. And there are two principal mechanisms called stretching and rotating. So because of these two principal mechanisms, the electric field can distort the charge distribution of a dielectric atom or a molecules. But there are some dielectric which are born with a permanent dipole moment. Hence, the molecules of a dielectric can be classified as polar and non-polar dielectric. So, the matter is composed of atoms and molecules which are electrically neutral. The atoms and the molecules have an equal number of electrons and protons in them, or an equal number of positive charged region and negative charged region in them. A nonpolar molecule is one in which the center of gravity or the center of mass of the positive charges coincides with the center of gravity or the center of mass of negative charges. The nonpolar molecules have a symmetrical structure and zero electric dipole moment. Examples are symmetrical molecules like hydrogen, nitrogen, carbon dioxide, etc. So, in the case of carbon dioxide, the oxygen ions are symmetrically placed with respect to carbon ion. The center of mass of the two O- ions, and it will be in the same position as the center of mass of the one C plus ion. That is, the center of mass of the two O- ions coincides with the center of mass of the C plus ions, and hence it is a nonpolar molecule. And also here we can calculate the electric dipole moment. The dipole moment which is directed from the negative to positive. And hence here we can consider the dipole which is directed from the negative O minus to C plus in one direction and the other one in the opposite direction. Hence the net dipole moment will be 0. So in the case of a nonpolar molecule, the net dipole moment is, or it has a 0 electric dipole moment. A polar molecule means positive and negative charges separated by a distance. A polar means positive and negative charges separated by distance. A polar molecule is one in which the center of gravity or the center of mass of the positive charges is separated from the center of gravity or center of mass of the negative charges by a finite distance. It acts as a tiny dipole. An electric dipole means two equal and opposite charges separated by a distance. So it acts as a dipole and they have an intrinsic permanent dipole moment, and this polar molecule arises due to the asymmetric shape of the molecule. Example H2O, HCl and carbon monoxide. In the case of HCl, the hydrogen ions and the Cl minus ions, the positive charged hydrogen and the Cl minus ions are separated by a finite distance. The center of mass of the positive charged region, center of mass of the negative charged region are separated by a finite distance. It is called polar molecule. Also in the case of H2O, water molecule, the center of mass of the two H plus ions and the center of mass of the O minus ions separated by a finite distance, and hence it has a permanent dipole moment.